Assalamualaikum and good day everyone. My name is NABILAH and together with our teammates SYAFIQAH, SYAHIDAH and NURIN and QISTINA, we will be presenting our assignment entitled Descriptive Statistics.
My name is NURIN and BINTI and I will present about introduction and objectives of this project. Now I want to talk about introduction for this project. Rainfall is formed when saturated air is held and raised either by a mountain, convectional currents, or frontal actions. Malaysia has a unique climate characterized by heavy rainfall, averaging 200 mm to 400 mm annually. The high volume of rain is influenced by the northeast and southwest monsoon seasons. Malaysia also experiences high humidity at until 90% and uniform temperatures 26 Celsius until 28 Celsius through the year. Next, this project has three objectives to be achieved. First is to analyze the annual rainfall trends across different states in Malaysia. Second, to identify the areas with the highest and lowest rainfall amongst each year. Lastly, to calculate and evaluate the overall national average rainfall to detect any significant yearly change.
Now, let me walk you through the methodology behind this study and how the data was collected. The rainfall dataset was taken from secondary data published by Jabatan Meteorologi Malaysia. It reports the annual average rainfall across all nation states from 2013 to 2017. This source was chosen because it is reliable, comprehensive, and allows us to compare rainfall distribution trends over 5 consecutive years. The study covers 14 states and federal territories, each rainfall records for 5 years. This gives us a strong basis to understand climate variations and regional rainfall patterns across Malaysia. This means the focus was on describing and analyzing rainfall distribution rather than testing hypotheses. The data was processed using Microsoft Excel to generate frequency tables and descriptive statistics such as mean, minimum, maximum, and standard deviation. To make the findings clear, rainfall trends were visualized using bar charts and also histogram, which highlight significant variation across states and years. In terms of variable, the study looked at 3 key aspects. The first one is state, which is a qualitative categorical variable, which is representing each major states. For the second one is annual rainfall. It is a quantitative continuous variable which measure in millimeters. And the last one is years. It is a qualitative ordinal variable showing the sequence from 2013 to 2017. So, as you can see in the table, rainfall amounts vary significantly across states. For example, Terengganu and Kelantan are consistently recorded higher rainfall compared to states like Selangor or Kuala Lumpur. These differences are important in understanding regional climate behavior. So, in summary, this methodology ensures that the analysis is systematic, reliable, and provides meaningful insight into Malaysia's rainfall distribution trends.
Next, I will explain the graphical presentation of the rainfall data in Malaysia from 2013 to 2017. This slide contains a bar chart and a histogram that helps us visualize the rainfall patterns among different states. The bar chart shows the average rainfall for each state over the 5-year periods. We can see that Terengganu, Sarawak, and Kelantan recorded the highest rainfall average. In contrast, Negeri Sembilan and Melaka had the lowest rainfall average. The histogram shows the distribution of rainfall value. Most states recorded rainfall between 2,000 and 3,000 millimeters. Only a few states experienced very high rainfall values above 3,500 millimeters. The distribution is positively skewed because a small number of states have much higher rainfall compared to the majority of states. After looking at the graph, I will now discuss the statistical analysis and interpretations of the rainfall data. The mean rainfall is 2,450 millimeters, while the median rainfall is 2,300 millimeters. Since the mean is higher than the median, this suggests that several states with a very high rainfall have increased the overall average. The rainfall data also shows a large range, and high standard deviations indicates that rainfall level vary greatly between states. The data distributions remain positively skewed, with most states clustered around 2,000 to 3,000 millimeters, and only a few states recording extremely high rainfall. Based on the analysis, coastal and east coast states such as Terengganu, Kelantan and Sarawak generally receive higher rainfall. On the other hand, states such as Melaka and Negeri Sembilan consistently recorded lower rainfall. Overall, the analysis shows that rainfall is not evenly distributed across Malaysia, which is important for climate studies and water resources planning.
In conclusion, this project helped us understand the rainfall pattern in Malaysia from 2013 until 2017 through statistical analysis and graph. We found that some states, especially Terengganu and Sarawak, received much higher rainfall compared to other states like Melaka and Negeri Sembilan. By using mean, median and mode, we were able to summarize and compare the rainfall data more easily. The graph also made it clear to see the difference and trends between the states. Throughout this project, we learned how statistics can be applied to real-life data and how factors such as monsoon season, weather conditions, and geographical location can affect rainfall in Malaysia. Overall, this project improved our understanding of data analysis and the importance of using statistical tools in research. Thank you.